Hi, this is Dale Rhoda. Welcome back to the Survey Scholar video series. This brief video is going to introduce some ideas associated with calculating coverage confidence intervals. In the next several videos, we'll extend these ideas and demonstrate them explicitly. As we've mentioned in earlier videos, at this time the WHO guidance to you is to report confidence intervals when you calculate indicators that are weighted and that draw conclusions about the population of eligible respondents. It's traditional to report a two-sided 95% confidence interval. You've seen those before in many types of scientific reports. And as a reminder, the way we interpret the confidence interval is with a sentence like the following. If this survey is free from bias, and if we repeated a bias-free survey process many times, and each time we calculated the 95% confidence interval for those survey samples, approximately 95% of those intervals would contain the true unknown population coverage figure. Now that's quite a mouthful, but that's the sort of clearest and most accurate interpretation. Sometimes we abbreviate that and we say we're 95% confident that coverage is inside the interval, and that's okay, but when pressed we should be able to give the full definition as well. Well, once you begin digging, you're going to find that there are 10 or more different formulas to calculate confidence intervals for a survey proportion. So the question arises, which one should we calculate and which one should we report? And the answer is that it's in many cases we should not use the default choice. The most common formula for a confidence interval is called a walled interval. It's the one that's most commonly taught in your statistics classes, and the formula looks like this one. The confidence interval is equal to the point estimate plus or minus usually 1.96 times the standard error. The walled interval is also the one that's calculated by EpiInfo in the tables of complex sample frequencies and complex sample means. And in this course, we do not recommend using the walled interval if you have access to any program other than EpiInfo that will do these calculations for complex samples. So you can use EpiInfo and report the walled interval if you must, but we prefer that you use something else. Just generally speaking, the types of intervals we want to report, well, we want the interval to have limits that are between 0% and 100%. Obviously, it's silly to say that coverage is lower than 0%, and it's silly to say that coverage could be higher than 100%. But the walled intervals sometimes report limits that are outside those bounds. And then I'll show you a graphic in a moment illustrating the point that intervals should be asymmetric when the coverage is near 0% or 100%, or if the sample size is small or moderate and coverage is not 50%, then we want the confidence interval to be asymmetric. And the walled is a symmetric interval, so that's another strike against it. And really, we want to use the same confidence interval formula here in the analysis phase of the project that we used at the start when we calculated our sample size. And so for these updated WHO guidelines, that's going to be what we call a Wilson interval. So we really want to use Wilson intervals for the most part. And to be technically specific, the sample size calculation uses a Wilson interval that has a continuity correction. Now, if you're curious and you want to read more about different types of intervals and why you might prefer one over another, for reasons beyond those I've listed here, you could look at this article. This is a nice article by Dean and Pagano in 2015. And then if you get more curious, then you can go back and read the articles that this one cites in particular. So here's a figure that shows some inchworm plots of walled intervals and Wilson intervals. So you can see over on the left, the red ones are walled intervals. They're all symmetric with a point estimate in the middle, and they extend essentially 2 standard errors to the left and 2 standard errors to the right. And so we have estimated coverage here of 50%, 70, 90, 95, and 99. The estimated coverage appears in this column over on the left. And then the green intervals are Wilson intervals. when coverage is 50%, the Wilson interval is essentially the same as the walled interval. It's symmetric, and its limits are the same. We can see that by adding these bars here at the tips of the intervals. But as we move closer to 100%, we see that there's a pretty substantial difference between the walled and the Wilson. Now these confidence intervals, they're calculated on the same samples. Each pair is calculated on the same samples. Well, here we see that the walled interval, that the upper limit, first of all, it exceeds 100%. It goes up to 100.9%. That's just silly. The Wilson interval appropriately keeps all of the confidence at or below, actually in this case below 100%. So this is definitely preferable. Then as we move back down closer to 50%, the intervals, they begin to come together. They look more like each other, but the walled is still asymmetrical. It has a longer tail pointing toward 50% than pointing toward 100%, even though it has the same point estimate as the walled. Perhaps I said walled up here. The green one is Wilson. Pardon me if I said it wrong. When we get down to 90%, again, they're coming closer together, but we're still asymmetric. We get down to 70%, and you have to look pretty hard to see that the Wilson is asymmetric, but it still is. In this case, the asymmetric is more appropriate. That's the one that we want to report if we can. Most programs that deal with complex survey data will give you a Wilson interval for a proportion if you ask for it. Stata, SPSS, R, and SAS will all do it. Now, it's possible that EpiInfo does it. I can't see how to do it in EpiInfo. I don't think it does for proportions, for survey proportions. But we'll contact the team and ask them, and if it doesn't, then we'll recommend that they include that in future versions of the program. Now, the next two videos that are coming, they describe how to calculate coverage with a confidence interval in EpiInfo and in Stata. And they give step-by-step instructions. And I wanted to just make a request of you students in the class or other instructors, if you'd like to type up some instructions to share with us of how or make a movie of how to calculate coverage with a confidence interval using SPSS, which I don't use, so I don't know how to do it, or using R. If you would do that and share the resources with all of us, that'd be really terrific. Thanks. If you have any questions, as always, post them, please, in the Survey Scholar community update where you found the link to this video. That'll be great, and then we can have a dialogue there and we can all see it. And if that's not working for you, then you can send me email or send email to John or Carolina Donavara here as well. Thanks very much.